question relevant to this page or not? Yes or no. This is, I should have probably not called this the RAG prompt. This is more the guardrail prompt. And then you have the relevance prompts. So this is, when I stuffed that up, explaining that. This one here is the guardrail prompt. And then this one here is the RAG prompt. So you can see I have a couple of little like prompt engineering if you're into that kind of terminology. Yeah, I've just covered a couple of examples of what's relevant, what's irrelevant. I tried to use things which were examples but which weren't included within the benchmark dataset that we'll see in a second. Pre-process documents, so this is where I start to actually pre-process all our documents and stuff like that. If we go down here, we can actually see that we get our text documents and it's detecting the encoding because I had to change the encoding. So then I could transfer them into a PDF format, and then for all the PDFs which were then extracted or which were created, then we turn that into images. So if we go here, instead of just talking about it, I don't really need to run that kind of stuff, and this has already been ran because I just ran it before. So if we go pages, and if we go here, 0. So we get our pages. I did resize them, but that was more to do with like a GPU limitation issue. And so because I was limited, I wanted to speed up the operations and all the computations in that, so I reduced the size of the documents. And normally the reason why I chose Gwen as a model was to leave documents in their natural image resolution. So I wouldn't do this in a production setting, but just because this is an example and stuff like that, I just didn't want to have to worry about not having enough memory, and I was trying to use free resources. So yeah. So in the end, we had a total of 10 pages. And so what I ended up doing was, based upon those 10 pages, I said to GPT 4.0 to pretty much generate 3 relevant and 3 irrelevant questions, and also give the response of what it would try to answer. You can see pretty much for all the pages except for number 6 down here, because when you look at page number 6, if I go back here, go pages, and if I go number 5, should be this one. Yeah, so there's not much you could ask. So I decided one question was more than enough, and to not go crazy with it, but I still wanted to make sure there was equal relevant and irrelevant questions. So I just did the easiest solution and said we'll just go 1 relevant and 1 irrelevant question, but all the rest you'll have 3 for each. I did go over and have to check some and have to change them a little bit, because some were I stuffed up a little bit with the questions on some of the pages and that, so I did have to go through some sort of like human validation. So yeah, and then you end up with your golden data set, your benchmark, or your ground truth data set, depending on how you want to call it. And then we go into the embedding model. So here we run, for starters, our image embeddings or our document embeddings. So that will then when we go here, this will actually put them into the database. I ran the images one by one because I just wanted to, I couldn't run them all because of GPU constraints, and 2, because I'll then run all the GPU, all the queries one by one as well. I wanted to try to get some sort of fair metric on representing the processing times for images and queries, and obviously to show that processing images takes longer than, say, processing text. So yeah, that's what I did, and I did that for all the queries. And so I'm tracking latency and stuff like that. And here, maybe I could have done that a bit differently, but I think it's fair what I've done, where I've literally said I'm going to calculate the retrieval latency for one query given the 10 pages or given the 10 images or the 3 documents, depending on how you want to describe it. And so then I can also compare retrieval latency. And one of the cool things is, because that would be in a production setting, a more server-side operation, it means then you only have to worry in like when you're setting up the embedding model, you would only have to worry about your generating your embeddings, which would then be stored into the Postgres server, and then it would be your Postgres server, which is then you would be off-putting some of that computational work to the actual Postgres server when calculating the similarity scores. So then what I did was I just calculated the accuracy based upon what documents was considered relevant and irrelevant. And so what we can see is we got to about 78% for top 1 accuracy. Top 2 you got 92, and then top 3 you're at 100%. So you've got so if you take 3 pages, you're for sure going to get your the document or the page that you're looking for based upon the question. I did have it was at 100% for top 2 when I was calculating it in memory instead of on the Postgres server side, so that is an issue that would have to be solved. Load the LLM. Yeah, so now here, this is where we're not even worrying about the embedding model. So simply what we're trying to look at here is implementing a guardrail and determining is that question relevant based upon the page or not. So this is going back up to our data here where we've created relevant and irrelevant questions. And so I use this package or this library which is called Outlines, and it works as pretty much like structured outputs for Hugging Face models. So I use that to then, because it was pretty nice, the integration, and it works pretty well and it's pretty easy to use. So yeah, just going back to the model, and so I'm using the 7 billion parameter Gwen 2 vision language model. I did try the 2 billion and it performed decently well as well, but to ensure that I had like some really good results, I wanted to use the 7 billion, and because I had enough GPU resources, why not use it? Computational times were slightly longer for the 7 billion, obviously. So here all we're doing is, over every question, we're going to use that prompt that we had up before, and we're going to include our JSON schema. So we're including our question and our JSON schema, which is literally just going to be, is this question that I'm giving here relevant or irrelevant to the image or the document, right? And so I do that, generate the output. So when you get the output, you will be able to see it as like this, and it comes out literally exactly like how it would with OpenAI structured outputs. So you'll get like this, where you'll get your object, because we defined our pydantic class like before, and so you're going to get question relevant, or irrelevant, okay? And then all I do is I calculate the accuracy score. Because there's an even number of relevant and irrelevant questions, I haven't got into like imbalance accuracy scores or anything like that. I wanted to make it simple. That's something where maybe in a production setting you would have to worry about that, because you would most likely have many more or much more relevant questions than say irrelevant questions, and so you would use a different metric in that case. So once that all happened and you passed the guardrail, and so I measured it, then we got into our response, so our Q&A. So here we went and we literally take our question and we apply exactly the same model, except here we're not using some sort of structured output. It's just using It's using the page, it's using the freeform output, it has the option of responding in however it wants, given the prompt and given the other information, so the document. Okay, and so, yep, so you just apply your template, calculating certain scores here, like Rouge and stuff like that. You're also getting the BERT scores because you don't want to just look at like if words are identical, you want to also know, are you capturing the same semantic information? And I'm just capturing like latency and stuff like that. One thing I did forget to mention is I am using MLflow to log all this stuff, and that's how I wanted to use that as my observability like library, and because I've never used it before, and I thought it was a good way to learn about it, and I think it's okay. I think MLflow could be a lot better. At my job, I use we use a paid service, so it makes it a lot better. I did find out this one today, which is called Pydantic Logfire, and it looks pretty amazing. So I think I might give that a try in another project. But anyway, yeah. So, and then here we've just got you've just got your target response, predicted response. So here you can see it's not responding in the same way, and it's not like 100% clean, the response. So maybe I should use some sort of structured output. But you do see that it's saying like I can't give a clear answer and stuff like that. You just start printing out your Rouge scores and your BERT scores, and you can see that it's not responding in the same way as in with the same words, but it is capturing the same sort of semantic information based upon your BERT score. You got your latencies, all that kind of stuff, clean up, and then so at the end, I'm just cleaning up and shutting down MLflow, because I am using UI. I am using MLflow, so you can just go like this, and the platform I'm using is actually Lightning AI. So they give you a couple of free resources and that. It's not a plug or anything. So you just got to open up your port, and then you can go to here, and then you can see your runs. Okay, so this is the run I just did like 5 seconds ago, and so I'm using that to pretty much observe and track all like your artifacts, system metrics, model metrics, and stuff like that. Yeah, I think that's pretty much a good overview of the code at least. And yeah, look forward to talking to you later on. Cheers.